for step 1 is simply to find f of negative 4. They've got a lot of wordy stuff right here, but if you just look down here, they're wanting you to figure out what's f of negative 4. Go to function f and plug a negative 4 in. Well, which one do you plug it into? Why the bottom one?
Oh, because it's equal to
Because it says if you are greater than or equal to negative 4, you use this function. If you're less than negative 4, you use this function. Does that make sense? Okay, so we want to plug it into the bottom function, and so that's going to be 3 times negative 4 minus 1. So you might want to write that out to the side there for your notes, or underneath that, 3 times negative 4 minus 1. F of negative 4 is equal to that. Okay? And we're plugging that into the bottom function. So that's negative 12 minus 1, which is negative 13. So this is a 3-step question, so I'm going to type that in. Does everybody have that written down because my ink's going to disappear? Okay. All right, so I'm going to type in a negative 13. Is that what we said?
Yes.
Hit enter, and we'll see what step 2 says. Step 2, same type of problem. This time they want you to find f of negative 6. So f of negative 6 would need plugged into which one? Okay, so I'm going to plug that one into the top one. And that's 2 times negative 6 plus 6, which would be negative 12 plus 6, which would be negative 6. Okay? Everybody okay with that? So I type in a negative 6.
Yep.
Hit enter. And now we're ready for step 3, which says find f of negative 3. So f of negative 3 would be plugged into which one? Is negative 3 less than negative 4 or greater than negative 4? Okay, remember your number line on the negative side works the opposite. So yeah, it's going to be plugged back into the first one. So once again, we are going to plug into the bottom one. F of negative 3 would be equal to 3 times negative 3 minus 1, which is negative 9 minus 1. And negative 9 minus 1 is negative 10. So we'll plug a negative 10 in for that one. Does that make sense? Okay, so negative 10. And continue practicing. All right, so write this down as your example 2. Just write down this function right here. It's a 2-step problem. And the first thing they're going to ask us to do is to identify the general shape. To me, general shape means parent function. So they've got some parent functions down here for me to pick from. I would not draw all those in your notes. I would just graph what this one's supposed to look like, which we will do. So once you have it written down here, look at your sheet that you have of all your graphs and tell me which function that is. Okay, so for your notes, you might want to write, hey, this is a cubic function. And this cubic function has a x-axis reflection. How did I know that? Okay, because it's negative. And what does the 7/2 do? If it was between 0 and 1, it would compress, but 7/2 is bigger than 1. So because 7/2 is larger than 1, 7/2 is greater than 1, therefore this thing is a vertical stretch. Vertical stretch. Does that make sense? So I am looking for the graph that describes a cubic function with an x-axis reflection. Okay? Does everybody have this written down so I can scroll down to the graph so you can see that? And once again, I would not try and write all these in your notes. I would just try and write the one that's correct. So which one of these four graphs represents a x-axis reflection on a cubic? That one right there. So that's the graph I would draw in your notes. Okay? And it doesn't have to be exact. Just draw an x-axis, a y-axis, and then a curve, a downhill cubic curve. Okay?
How did you know it was cubic?
By looking at your sheet. It's a cubic because you had an x cubed in your problem, right? So when you go look at your sheet, you should look above the graphs, and right above the graphs is the name, the equations. So do you see the one with an x cubed? Okay?
Are we gonna be?
So that's how I know it's the cubic, by looking at the graph. Does that make sense?
Yeah.
When I see the x cubed, I go to my sheet, which you'll eventually have memorized, and it says cubic above this one. So that's how I knew it was a cubic function. Now this looks just like the one on your sheet, except for it's going downhill. The reason it's going downhill is because there was a negative in front.
Can you scroll up there?
Yeah, it's negative 7 halves x cubed. That's what should be up above.
Yeah, so I didn't put the cube part.
Okay. Yeah, that makes sense.
We're gonna be able to use our.
Not on the test. Nope, because you can't use it on the ACT, and you need to know it for that. Okay? Everybody good with that? Okay? All right, so submit. This is a two-step question, so what's step 2 going to be like? Step 2 says, hey, give me 2 points on this graph, right? So anytime you want to know 2 points on a graph, that means you get to pick x, plug it in, and then find a number. So what do you think we should pick? Probably 1 and -1 would be a good pick, right? You could pick 2. Then you would get a 2 cubed, which is 8. It would get rid of the fraction. So if you did a 2 and a -2, it would allow you to get rid of the fraction and not have to type a fraction in. So I don't care which way you do it. I'll show you both, I guess. But if you plug in a 1, it's negative 7 halves x cubed. So if you replace x with a 1, you're going to get negative 7 halves times 1 cubed, which is just what? Negative 7 halves? And what if you replace x with a -1? You put a -1 in there, now you have 4 negatives total, right? You got 3 here and 1 here, so you end up with a positive 7 halves, correct? And if you know it or not, what that means is you have an odd function. Anytime you plug opposite numbers in and you get opposites out, they call that an odd function. Okay? It's even if you plug in opposites and they come out the same. And that will show up eventually as well. So let's say you would have picked 2 or -2 instead. If you picked 2, then that means you would have a 2 in here. And that would be 2 cubed, which is 8. 8 divided by 2 is 4. And 4 times -7 is 28. And it would be a -28, right? Because you have 1 negative sign. If you plug a -2 in, then you get 4 negative signs, and it comes out a positive 28. So once again, we plugged in opposites, and we got opposite answers out. That's called an odd function. Okay? Everybody okay with that? It might not like the 28 because it's such a big number, it won't be able to show the point. Let me try that real quick. Everybody okay with this? Okay? So if I plug in the 2, will it let me plug in a -28? What's it say? Oh, that's because I don't have the other point in there. -2 and positive 28, right? Oh, it liked it. Good. All right. Next problem. Same type of problem, basically, only it's a absolute value function, right? So if you look at your sheet, for the one that has an absolute value, it's an absolute value function which looks like the v, and it's been stretched. So all I got to do is go down here and pick the graph. For your notes, you're just going to write this out. You can write absolute value with a stretch. And then you can draw a picture that looks like this in your notes. Okay, notice they didn't actually stretch it. They just have the parent function here. These graphs are just the basic graphs, not the actual stretch being shown. Okay? So I will select this graph to show I know it's the absolute value. I will hit submit, and then guess what they want for step 2? Oh, they want me to find 2 points on the graph. So once again, I would pick 1 and -1 to make it as easy as possible. So if I pick 1 and -1, and I've got to take 7 times the absolute value of x. So 7 times the absolute value of 1 would be what? Yeah, 7. And 7 times the absolute value of -1? 7. So notice on this one, when I plugged in opposites, I got out the same number. Whenever that happens, when you plug in opposites and you get the same number, that's called an even function. Okay? Even functions fold over the y-axis. So the absolute, see, 1, 7 is right here, 1, -7, so it's a really steep-shaped V. Okay? And so anytime something folds over the y-axis, that makes it a even function as well. So I'm going to skip that since we know what those are, rather than taking the time to put them in. Okay, so here is another piecewise function, so write this one down. Write down your function. Don't worry about writing this part down here. Just write this. Okay? Directions are a little bit confusing. It says identify the general shape or parent function of the graph that goes from -infinity to -2. Well, -infinity to -2 would be this thing right here. But all you need to ever really remember is that step 1 is always the top one. For step 1, you're going to pick the top one. Step 2, you'll pick the bottom one. And step 3, you'll put them together on the same graph. So as we look through all these graphs down here, what should you be looking for on this thing? What type of function is that? If you have y equals -3x minus 6, what type of function would that be?
Linear.
That's a linear function. Is it downhill or uphill?
Downhill.
So you're looking for a downhill line to identify the first function. Does that make sense? So for step 1, you might put identify the first function or top function or something like that. Okay? And we have like a bunch of them to pick from. We have 18 graphs to pick from. Okay? So identify the first function. We're looking for, what'd you say? A downhill line. So that's the second one. See all the choices we have here? Okay, they got an upside down absolute value, a square root, the cube root, and so on. So we want to pick the downhill line for the first function. So step 1, you should just draw a downhill line. Okay? Does that make sense? Okay, step 2, right? Step 2, identify the second function. Identify the second function. What would you expect the second function to be? That's not a square root. It's a quadratic. Okay, it's a quadratic that's been compressed, it looks like. They're not going to show you the compression on the graph, but you are going to look for a parabola that's a happy face. And you'll have both to pick from. Here's the happy face and here's the sad face. So if there was a negative in front, I would pick this one, right? So for the second step where it says identify the second function, just put a happy face parabola by it. Okay? Does that make sense? Okay, submit that. And then step 3 is going to want you to put them on. So look at these choices here. You have 2 things on the graph. Okay? So you have to decide which one of these accurately depicts this function. So make sure you understand that this is the breaking point. To the left of -2, you need to see this line. And you want it to have a closed circle on it. To the right of -2, you want to see this parabola, and it should have an open circle on it. Okay? So to the left of -2, I should see a downhill line. And then to the right of -2, I should see a parabola with an open circle. So when I'm looking at these, I'm thinking these 2 are one of the answer. I could probably eliminate these 2. Okay? Because I have a happy face parabola in both of these and a downhill line to the left of -2. So I need the downhill line to have the closed circle, so this is the correct answer. Does that make sense? Okay, so if you're trying to make that in your notes, you are just going to make yourself a little graph. You're going to show where negative 2 is at. I'd probably like put a little line here to show where the negative 2 is at. And then you're going to have a downhill line to here with a circle. And then an open circle somewhere up here. Something like that. Okay? It's kind of the way you can draw it in your notes. Does that make sense? So the key thing is you need to understand that the negative 2 is where the change occurs. So we scan across, when we get to negative 2, that's where we stop seeing the line and we start seeing the parabola. Okay? Is everybody good with that? And that was correct. Okay, so next example is the same type of problem, so I'm not going to necessarily do another one of those, but I'll just say for a second, what do you think this one would be? That would be a downhill line. Y equals negative 1/3 x. You could put a plus 0 on it if you want to be a downhill line. This one would be a what? That's a cube root function. Okay, so the cube root function there. This is like the first one we did, so I'm going to skip that one. So there's another one just like what we've been doing. That one's the downhill line, and that one's a quadratic. We did one just like that. There's another line with a cube root function. Let's do this one because it's a little bit different. Okay, so write down this function up here. Okay, so on this one, once again, ignore all the wordy stuff. Just look down here. They want you to find f of negative 1. So when you look up here, do either one of these meet that criteria? Is negative 1 greater than 6? Is it less than or equal to negative 5? It is not, right? It doesn't meet either one of the criteria. So what are we going to do? Undefined. That's undefined. So in this particular one, you would click undefined. So for step 1, you say find f of negative 1 and put undefined as the answer. Okay? Does that make sense? And then for step 2, now they give you one you can actually do. F of negative 5, so I would go to which function to plug in a negative 5? The top one. So I plug that into the top, and I would have 2 times negative 5 squared plus negative 5 plus 6. So you just have to be careful with your signs here. That's 25 times 2 is 50. 50 minus 5 plus 6. So that's going to be 51. You plug a 51 in there for that one. And I believe step 3 will do the exact same thing. It's going to ask you to find another one of those. And so I'm just going to skip that because you know how to plug in numbers. Okay, so what function do we have here?
Oh, you have a...
It's not a cubic.
Nope. You have a reciprocal function.
Okay, it's a reciprocal function because it has an odd power, right? Okay, so that is a... you could also write that one like this, 8/9 times 1 over x cubed. That would help you see that it's a compression. It is a reciprocal function that's been compressed because of the 8/9. And I have to go pick the appropriate graph for that. Okay? So, as I look for the appropriate graph, which one looks like a reciprocal function? That one right there, right? Everybody agree that's the reciprocal? So you just make a quick graph in your notes that looks something like that. Label it reciprocal if you would like. Yep. You're fine. So just write, for your notes, I would just write q of x equals this. Pick Now pick the graph. Okay? So there we go, submit. Next, and they're probably going to want you to find 2 points. Sure enough, they want 2 points on this thing. What numbers would you pick for x?
1 and negative.
Yeah, pick 1 and -1, so your answers are going to come out 8/9 and -8/9, right? So if I replace x with a 1, I will get an 8/9. And notice the point showed up when I did that. And if I pick -1, I will get -8/9. Whoops. And it shows the point. It doesn't really show the graph, unfortunately. Okay, now I've got a step function. Okay. So write this one down so we can practice with a step function a little bit. And so I wrote it a little bit differently. I took this -x/3 and changed it to a -1/3 x. This is the rare occasion where you get to see a horizontal stretch. Okay, this number would represent a horizontal stretch, and this would represent a y-axis reflection. All right? Instead of an x-axis reflection, it would represent a y-axis reflection. This number is going to be a stretch. And so out of these choices, everybody got that written down? Out of those graphs, obviously that one we can see there looks like it could be an option, right? So this graph right here is the only graph that resembles a step function, right? So we're going to choose that one. And so you can just write step function out there beside that one. And then hit submit. Now on this one, instead of asking you for points, they ask you for length, and they ask you for vertical separation. Okay, well, vertical separation would be like a vertical stretch number. So what number out here is my vertical stretch number? The 2. So the 2 is what gives me my vertical separation. So in your notes, you want to write down vertical separation equals 2. And length equals 3. Because that's this number right here is horizontally stretching it, okay? That's a horizontal stretch. That's a vertical stretch. So my vertical separation is 2, and my length of my steps is 3. So see how it stretched the steps out to be longer. All right, so put length equals 3, vertical separation equals 2, and then it will draw it for you. Does that? Nope, you don't want to put -3. The negative switch flips it over the y-axis, and they didn't ask you if there was a y-axis reflection or not, okay? So it's rare for you guys to see y-axis reflections, but on the step function, that's one they will give you one of those on, okay? Everybody okay with that? Length equal, yes.
Will the dots always be like open and closed?
Yep,
Okay.
because this one's, it would fail the vertical line test if they were both closed here, right? So this one's closed, that one's, and do you guys remember what the vertical, what the step function does? You plug a number in for x, like plug in a 5. If you plug in a 5, you get -5/3. That's the same as what, 1 2/3? The greatest integer function will spit out the largest integer underneath that value. So if I were to plug in a 5, just so you understand what this function does, if I were to plug in the number 5, that would be -5/3, which is the same thing as -1 2/3, right? So when I apply the step function to that, it gives me the largest integer below this number. So if you think about looking up there at the number line at -1 2/3, what's the greatest integer below that? Nope. Look at the number line over there above the board. find -1 and 2/3. What's the greatest integer below that? -2. So this thing will return a -2, and then you would multiply it times this, and you would get -4. Okay, so the 0.5 -4 should be on this graph. Okay, 5 -4. 5 -4, sure enough, right there. Okay, we land on one of the steps. Okay? All right. Next. All right, so this is just another one where you're identifying the graph, and then you're plotting 2 points. So what type of graph is this?
That is a quad, is that 15?
Yeah, we got looks like a fourth root to me.
And it's
So fourth root is a square root function, not a quadratic, right? Because of the root.
Oh, I see.
It's the inverse of a quadratic, okay? So when you look at these 4 choices, which one looks like a root function? Even numbered root function. That one right there, right? The square root function either looks like something shooting up out of the water or shooting underneath the water. This one's a negative, so it's shooting underneath the water. Okay?
Yes.
There's the function. V of x equals -2/9 times the fourth root of x, so that's basically -2/9 times the fourth root of x. So we have a x-axis reflection, a compression, and a fourth root. Okay? So that's the square root function on your sheet. Any even-numbered root looks like this. Okay? So for your graph, you can just do this and go, hey, it shoots under the water. It's a negative square root function. Okay? And so if you were going to submit 2 points for that, enter the coordinates for 2 points. What numbers would you want to pick? Now notice, I think on this one it will let you round to 2 decimal places. So if you pick a number that doesn't have a nice fourth root, then you can round to 2 decimal places, okay? So what is the fourth root of 1? 1. Okay, so we're going to do 1. Sorry, I meant to do that over here. Okay, let me do that again. Okay, so 1 fraction 2/9. Second one. Now I cannot use a negative number here, right?
Wouldn't it be -2/9?
Was there a negative in front of the 2/9? Okay, so yes, it would be. Okay, so now I cannot plug in -1 as an option, right? Because I can't take an even numbered root with a negative number, correct? So now I got to pick something that either has a even numbered root, or I can just pick a number and plug it in my calculator. You could. I'm not sure it's going to take 64. We can try it though.
Well, that takes
like the
one,
Or actually, what's the fourth root of 16?
2.
2. So I think we could try a 16.
Yeah, so 2 -4 is what
And so the fourth root of 16 is 2, and 2 times 2 is 4. But what you're going to run into though on these sometimes it's a cube root, and if it's okay to use a decimal. You know what I'm saying? If you want to plug 3 in for this, that's fine. Then just do a fourth root of 3 in your calculator times 2/9, and then use the decimal if you want to. Okay, but we said 16, fourth root of 16 is 2, 2 times 2 is 4, so let's see if it'll take a -4/9. Whoops. Does that make sense?
Yeah.
Submit. It liked it. Good. Okay, so we went through an entire set. So that gives you an idea. This is really an easier lesson probably than the last 2.